On the first exercise for computational physics, physics 154. So we're just going to get right into it. Our first exercise is to write a short code in Fortran to compute and display input and output values for the following functions: f of x. So we have 1, 2, 3, 4, 5 functions here that we want to show the output from. So first thing we want to do is open up our terminal. So we did that by going into applications, and within applications, utilities and terminal. That's the way it's set up on this machine. And now this tutorial assumes that you've already installed Fortran on your system. If you haven't done that, then there's some other video tutorials on that. But so we want to open our terminal there, and we also want to open an editor. So I'm going to use text edit because it's nice and clean. I'm going to make sure that if you're using text edit that you make it plain text, so you don't have any extra or invisible characters that you don't see displayed. Okay, and I'm going to, in Fortran, this symbol here, the exclamation point, indicates a comment. So whatever we put after this is not going to be executed. So what I want you to do is put your name here, then the course, and every line that you don't want to be executed, put an exclamation point. The title of the course, computational physics, course number 154. Let's say exercise 1. Okay. All right. And in Fortran, we're going to use just variables right now, not actual functions of x. And in Fortran, for variables, when you use variables, you have to declare variables ahead of time, so that the machine knows how to manipulate these variables, how to use them. So the variables that we use for the function, the variable that we're going to use for function is going to be f, and our independent variable is going to be x. So f is our dependent variable, f of x, and x will represent our independent variable, x, and they're both going to be real. Okay, and now we're going to work on this first function, f of x, first function of x. So f of x equals 5. So for this particular problem, x equals 5. And on the next line, we're going to say what f of x equals. So this is f of x equals x. Okay. All right. And then we're just simply going to print those values. So print x, print f, print x, and at the end we're going to say stop and end. And in Fortran 77 you have to, that's how you terminate your program. So this is just a simple program just to get our feet wet. Okay, so we want to save this. We want to save this to our directory. So this directory, if we type pwd, it tells us our directory is users. All right, JLead 101255. We're going to create a directory, a subdirectory, say class 154 to put this in. Okay, that already exists, so we're going to just copy it. We're going to change directory to that class. we're going to change to that directory. So now we're in class FHY physics 154. And we're going to, when we type ls, that shows us the contents of our directory. There's nothing there. But we're going to save our program that we just created. So we're going to go save as, and we want to change this txt, the extension txt, to F. And we want to name this something that's similar to that reminds us of what we're doing. So this is our first exercise, exercise 1, problem number 1. So EX1_1 is what I'm going to name it. And then I'm going to go to JLead class PHY154, and it might be different on your system, but this is where my file is located. And if you can't, I'll show you that. And we're going to save it here. Okay, so we go into there and we click save. Okay, so we've saved it. All right. Now, when we type ls, we're going to see that we have the file that we just saved there, EX1_1. And now we want to compile it. So G_Fortran, okay, X1F. Okay, type that, and it looks like we don't have any problems. That's good. And now when we do ls again, when we type ls, we have two files now. We have our source code that we created, which is this file here, and then we have another file that comes from the command that we just executed, the G_Fortran command. This is readable to us, but the computer doesn't understand any of this. It only understands machine language or assembler. So what the command that we just executed, G_Fortran, did, it took this text and it compiled it. That is, it translated it into a language that the machine can understand, machine language. And that is what A.out is. And so every time you use G_Fortran to compile your source code, and that's what this is, source code, it's going to create an executable, or this A.out file. And if you look at the contents of it, it's going to be complete gibberish. You won't understand it, but the computer will. So don't worry about it. And the way we execute it here on the Mac and Linux is we type period, / and then the name of the executable file. Okay? And when we do that, we're going to get the output from the file, 55. Okay, which really doesn't say much to us, right? Which one is, we're supposed to be outputting F and X, but we don't know which one is which. So why don't we do a little structuring of our output? What I'm going to do, this is what I did in class. I'm going to say F equals, I'm going to add two strings. Okay, right now I just have two variables here, F and X, F, X. And what you have to separate each object by a comma. So we've got two variables here separated by a comma. What I'm going to do is add a string, and that string has to have a comma behind it. And that string is going to be F equals, and I'm going to add a space here. So that's a string, F equals X, and your strings have to be in quotation marks, as I'm showing here, then the variable F, and then I'm going to put another string, x equals, okay, so I have a string f equals x, which f equals space, which is going to be printed or displayed literally. F is a variable, so its contents is going to be displayed. And then x equals is going to be displayed literally because it's in quotation marks, it's in double quotes, and then x is going to be displayed. So now we're going to save this again and then recompile. So G Fortran ex1 underscore 1 dot f. Okay, so a dot out has been recompiled, and we know that because the timestamp on it is different. This is 138, military time 1358, and that's how you know when your files have been updated. So we've got a new file. I'm going to execute it again. Remember, you have to have your period and your / a dot out. And now this is a little clearer. F equals 5, x equals 5. And this is exactly what we wanted to compute. So now, so that was very, very simple. So now let's go on to something a little more complex. And we're just going to gradually increase the complexity as we go on in the class, slowly. This next one is 10x plus 3. So how do we represent that? 10x plus 3. This is a linear equation. How do we represent that with our variables? So let's type in what that equals. 10x plus 3. We'll just type it in straight, directly, without doing anything to it. And this is not going to compile. So let's save it. I'm just gonna demonstrate something about why we're going through this exercise. You'll get the understanding of why we're going through this exercise. So G Fortran x equals x again. We're gonna compile our source code again, and we have an unclassifiable statement. We have an error. Our compiler was not able to understand everything that we input. What happened was, well, two things. One, we didn't define what F2 was. Is it a real variable? What is it supposed to be? And we have a 10x. The computer doesn't understand that. It doesn't know if it's supposed to add 10 to x. It doesn't know if it's supposed to divide 10 by x. It doesn't know anything. So what we have to do is add an asterisk here. It's implied here. It's implied when you write it down analytically, when you're doing your homework and everything. But in the machine, for the machine, you have to specify what operation you're using. So in this situation, we're using multiplication. So let's save this again, and the error should disappear when we compile again. So I'm going to compile, and I just hit the up arrow. And it'll let you dial through all of the history of the commands you've used. So just a little hotkey shortcut. So that compiles. I don't have any error messages. And I'm going to run it, but again, we're not going to see anything because we haven't put the output. We haven't displayed output, but you'll see that we still have the same thing being displayed down here. So what we have to do, I'm just going to copy this. Say F2 x, okay? And I'm going to save that. Compile again. You always have to compile again and make sure that your file is up to date. Yep, we just compiled. So this is our new compilation. The file is overwritten every time. And I just compiled it. run a dot out. We have f2, f equals 5, x equals 5, but we also have the value of x2 displayed. f2 is 10 times x is 5, so that's 10 times x, which is 50, plus 3, so 53. So x equals 5, f of x equals 53. So we just do the same thing for all these other for these other functions. We've got a second order polynomial here. All right. Okay. So we're going to type 25, and remember we have to always indicate what operation we're using between two terms. So this is 25 times x, and x is squared. And in Fortran, the way you represent exponentials is 2 asterisks. So this means x raised to, this represents x raised to the second power. So that's how you indicate exponentials. So we have 3 times x. Again, you have to be explicit with the machine. Minus 20. Okay, so let's compile that and see what we get. Note we want to print out our output. It's not going to display unless we print our output. So this is F3, I'm sorry, and F3 equals x. Okay, so save. Okay, we've saved it, and now I'm going to compile it again and run it. So a dot out. So we got this. 25 times 25 is 625. Plus 3x is 15, which is 140 minus 20, which is 620. So we have the correct value for F3. Okay. So now let's compute the next function. And we'll call the next function F4. We'll declare it here, F4. And F4 equals sine. I'm sorry, 10 times sine. Okay. Pi, which is 3.1415 to 654 times x minus, I'm sorry, divided by 2. Close parentheses, make sure your parentheses are balanced. One opening and one closing. So we've declared the variable f4, we've assigned it a value, we've assigned x a value, and now we want to display it. Print. Okay, so our string, we want to let ourselves know what we're actually printing out. The variable we're printing out, comma, another string telling us what our independent variable is, and then our independent variable, which is x. Then we want to save that, which is also Control S. Control S is in Sam. Compile again. That's gfortran x1_1.f. Enter, and then period /a.out. So this, we've displayed the value of this trigonometric function, and this is going to be in radians. Okay, the input is here. It's not degrees. The argument here is not in degrees. It's in radians. So So that's to say that if you put pi over 2 here, okay, and say remove the 10, say pi over 2, then we should get a value of 1. F of 4 should equal 1, okay? So let's save this. Okay. Compile again. G4 Get that out. So we've got x equals 5, but pi equals 1. It doesn't really matter what x equals in this situation, in this function, this particular function, because f of 4 is not dependent on x. You know, we took x out of the formula. But that was just a demonstration to show you that this argument is not in degrees, it's in radians. So otherwise you might be confused with the output. Okay, so our last function is f equals 5. Let's declare it up here, and then let's assign it. It's supposed to be e to the x. So you might think that you can just do this, but you can't. That's not the way it's represented in the machine. To the machine, you don't represent it to the machine that way. It's a function, it's an intrinsic function. Exponential equals x. Okay, so we've declared it, we've calculated it, or assigned it a value. Now let's display it, and I'm just going to copy this here, but you can type it. Okay, f of 5 equals the string f of 5 equals 5. Okay, now we're going to save this again. We always have to save it, compile it. This is the routine, and execute. Okay, so x equals 5. E raised to the 5th power is 148.41316. So that's the first exercise. So there's a homework assignment that's similar to that, and the homework assignment to this is you can get it in the PowerPoint, or you can also click on the link in the box in the description box below. And so if you have any problems with this, please email me. But otherwise, you finished the first problem of exercise 1.